Hello everyone, and welcome to today's live stream, where I'm going to be going over my geometry nodes, Armature system, and all that cool stuff, the virtual bones and physics and all that cool stuff, with some new stuff later on. So, from where we left off last time, I took a look at Blender's Wiggle Bones add-on to see if I was missing anything with my physics setup. And turns out, or the wobble setup, and turns out mine was very similar to theirs already. I just had to make a few fixes, and it's very similar. And it's so similar that it also has the same errors when dealing with too many bones that have physics on them. You can see here that the motion is very wavy, which is expected. Like if I turn off the dampening, we can see that this stuff happens, which, yeah, that happens with the Wiggle Bones add-on, which unfortunately I just did not test beforehand. I thought it didn't have that issue. But just with when you're doing these kinds of physics on bone chains one direction, it takes the errors start to build up because the parent is not affected by the child, just the child is affected by the parent. But it is still very cool, very, very cool. You just need to turn up the dampening so that the weird stuff doesn't happen, but that dampening is a bit too much. And I also added an angle limit, so now the bones can't go over a certain limit, and I can specify that. So in this case, let me set it so that the limit is 6 degrees. Here we can see that they're all limited to just that. Let me turn the dampening up a bit more so that we can see that. So let's set this to 25 degrees, and I'll also show you the internals. So the way that this works is that we have a bone setup, which I showed you before. In this case, the bones are a 4x4 matrix made from an bunch of edge lines with some cool stuff in between. So this is the setup for setting up the bone, getting the parent ID and the chain ID, and then getting the matrices. And then, oh yeah, we set to global space, and then we set the orientation. Well, that part's not really needed. And then we set the tail position, and this position is what drives the physics. Same thing happens in the Wiggle Bones add-on with some changes I just made for convenience sake. So you make that have velocity, and you make the velocity go do stuff, and then it goes and makes the bones do their thing. So inside of the stack transform setup, we have all the stuff that has to do with the physics. So in this case, we constrain the position and velocity. I want to get rid of this, but apparently I can't really. It has to be done before, and it can't really be done inside of the repeat zone, or else things get a little bit funky. And that's one part that separates from the Wiggle Bones add-on. And then you recalculate the velocity in post using this setup, and then all this is just to align the bone with either its parent or how it's supposed to be, or make it rotate to align with the physics-driven tail position with a limit vector angle setup, which I made, which is very cool. This is the setup. I wish I could have gotten rid of the vector rotate and just used dot products, but it was so convenient, I was like, I'm just going to use that. But yeah, so you can limit the vector angle from that. It's complicated, but I wanted to make it, as a proof of concept, just feature-rich. Because you could always trim stuff out when you want to, I don't know, if it ever becomes practical. Which in this case, I don't know if this is even practical in the slightest. But it's cool, especially when we get stuff like this going, yeah. Yep, let me go and attach the dampening again so that we can see a more regular result. But yes. So, the main thing that I was working on today, which actually didn't take too long, is making the bone skin to a mesh correctly. So before, I would take the distance to an edge, or use sample nearest and then get the edge index, and then do all this to make it so that the bones would get automatic weights and then make the shark deform. But the problem was, when there was branching, it would not work correctly because it would either choose one bone or the other. And I was like, I can't make it actually use the actual weights. I'm completely ignoring the actual weights that come from this model because we can't just go through the list of weights in geometry nodes. We can't go and see how many vertex groups there are, run through all of them in the list, and then just do it. So I was like, you know what, we can just try to do it procedurally. So in this case, this will be simplified. That's what I'm going to do today. But what it does is it gets the bone transforms, in this case the matrix offset, converts the bones to edge lines, and then samples that onto the shark, and then moves that. It goes through every single bone in the setup, automatically creates weights, stacks up the total weight so that the offsets can be normalized, sample this, get the normalization, scale it, all that good stuff, and then apply it. Which actually, no, that all works just fine. So with all this, it's working very... I have not looked at the actual Armature deformation code. This is me just going off the top of my head, but it could be fun to see. So that's why I am working on it. It's a proof of concept, but it's been very educational. So the main thing that I'm going to do now is change it so that the skinning will not have to work on edges and not use the geometry proximity node because this is extremely expensive being repeated over and over. That's a leftover from the previous version that didn't use a repeat zone because this is expensive, 9 milliseconds. Ideally, it would be less than 1, but I don't think we'll get there. But yeah. What we're going to do instead is just ignore. We're going to convert... We're going to keep these... Oh, we could even keep these as instances. We can even start this as instances and avoid the points altogether, but that might be a bad idea. It may be better... Yeah, we'll convert it to points just for simplicity's sake. Do we need to? I don't know. I actually don't know. Hello, how/where would someone start learning about geometry nodes? It looks overwhelming. Well, this setup looks overwhelming because it is. I'm doing stuff that you're really not supposed to do inside of geometry nodes. But it's fun. So that's, and educational, which is why I'm doing it. I would recommend looking for beginner tutorials on YouTube and looking at my little tips and tricks videos. I haven't done proper tutorials in a while just because I'm still working. I'm too busy working on advanced stuff, if I'm being honest. But Arendelle makes good stuff and has a beginner course, so I would recommend taking a look at their stuff. And Geometry Nodes starts off simple, and you can get very far with the simple stuff. I'm choosing a very difficult path because masochism? Maybe just, it's a challenge. I like challenges. Yes. And for those of you who are wondering why not use the Wiggle Bones add-on, if you're in a production, use the Wiggle Bones add-on. Don't use this. This is an experiment. Use Houdini, use all of those. This is an experiment. So, let's go and start converting this to be optimized and to actually use all this correctly. So this is, this will be the skinning. There we go. So, what we're going to do is make it so that we don't need any of this, except maybe you. We may need to move... Well, actually, no. We could just... Yeah, we're going to completely ignore the root position with this setup. So let's go and just connect you to there. And we don't need you whatsoever. We just need you as points, which is very nice. Look at that. So simple already. We may even be able to put everything inside of the node group. So here, we will change you to be a point, and over here, we will also sample each point's index. So this will be points now. So we're going to go through and get the proximity to every single edge line, and then turn that into a weight, which will control how much weight each bone has. We stack up all the offsets, and then we divide the offsets by the total weights to normalize them in quotes. And then we add that to the position, and everything should work fine. It will work fine, because this is, pretty good. Oh, wait a minute. There is something that I did not take into consideration. I'm still sampling the transform offsets, but I may need the actual transform. Why not use both? We could use both. Yeah, let's go and do that. So we have the points, we're going to go and sample those by the index, so we do not need you, or you, and we just need the transform global, and then we can go and separate the location, rotation, and scale, and we will just need the translation for the time being. So here, if we want to do this the dumb way, which is not the correct way, we can get the position and then put that into the distance. And then here, should be working already, but something is amiss. What is wrong? We have the distance. That one's being sampled correctly. It's on the point. We're getting the transform global. That's going over to there. That's being put into there. We have the points that get put into there, and that's good. What is the problem? I really should move it so that this index line is up here instead of down there, just so that it's out of the way. That's the one. I wish we had the portals, because spaghetti is not my biggest fan. Okay. So we have that. We get the transform global. We sample the points, so it's going through. Oh, that's why. We change this to point cloud. Yeah, that'll work just fine. So now this will go through every single point, and we can see that that is doing something. Oh, wait, it's going back to the rest, right? Instances to points, correct. Oh, wait. We need, yes, the rest transform. That's the one that we needed. There we go. So now it's already working a lot better than I expected. That is unexpected. I thought I would need to do more, which I will need to do more. Okay. So here, let's go and remove these from the frame. Are you removed from the frame? No, you are not. Remove from frame. And then we can put this over to here. Then there we have the distance, and I'm using a mix to mix between the original position, but wait, we don't even need to do that. We are getting the offset, but I could just, yeah, no, that was dumb. We take this and then we scale it to 0 or we scale it based on the weight. That's a little less dumb. Then we get the offsets and we do all that, so we should see if I need to, do I need to invert that? Oh no, maybe I was correct to ignore that. We get the offset, so we get the position, we get that, we do that, and that should be fine. Why is that accelerating into the moon? Oh, that's because, for some reason, yes, we need the actual weight. There we go. Now it's working again. So here we eliminated a ton of parts that aren't necessary, and also, oh, that's lovely. Separate transform, and actually we don't even need to set the position anyway. We can just remove that as well. Yes, no, that's completely unnecessary now. We don't need you either. But we will need you to simply... Here. This is getting simpler by the minute. We will need you because I will need to get the distance for the quote-unquote edge that exists. Basically mixing between the bone length and all that good stuff. So here we have the position of the bone. That's the 4th column. This part right there, that's the location, and this is the Z offset. So this, if we add these both together, this will be the tail of the bone, and this will be the head of the bone. So I just need to figure out how to make it work properly. Which I did it before, but I may need to reopen the blend file in order to actually make it work. I'm getting annoyed by you being up there, so let's bring you down there. The most annoying thing about geometry nodes, which is also its greatest strength, is the node noodles. That's why I like it. I like the node noodles, but sometimes you wish you could just, you know, named attribute it away. Which I'm not going to do, because that would be very, very annoying to deal with in the long term. There we go. Yeah, we're just gonna put that there again. We could hide that. No, let's keep that open. So, how do we get the distance between all this? Well, I could just mix between A and B to get the middle of the bone, but that's not the best idea. Here, let's go and get rid of that. It should be better than that. We need to get the actual distance based on the length of the bone. So how do we do that reliably? Well, the way I think I remember doing that before was to use a subtract, get the position between those, And then you go and get the dot product between the edge vector. Yeah, we get that, and then we use a dot product, and that'll give us the length along the edge here. Need to remember then here we need to get the total length using... Oh, do we use the distance? Well, we could do that. That'll give us the length of the bone. So if we have that and that, we can then divide these two to give us the total length along the bone. But no, I want to get the actual distance. So how do we do that? I may need to look at the other thing that I worked on. Because right here, this dot product will give us the distance along the bone. Which, since this vector is not normalized, that should give us the correct thing. So this will... But, Wait. If it's off to the side, then that might not work as well. I may need to go and look at that thing again. So we already have a result that's working, in quotes, but not working all too well. So again, if we mix these two, we already get something that works. So again, if we get the distance between here, it'll give us the distance to the center point of each bone, which in some cases is desirable, but not in our case. And also here, I'm going to use an integer math node, so that that'll get offset by 1, so that we ignore the root bone, and then here we're going to subtract that by 1. So now the root bone, which is necessary, but it's just kind of the... Just because of how bones are set up, that just has a default location, rotation, and scale, and it's also just used as the anchor point. So we're doing this to ignore the root bone, so it just won't be calculated at all. In terms of speed, whoa, that cut it down by over half. Oh, not bad at all. Though it is still too expensive to be practical. Or is it? I don't know. But since we have all this data, all I need to do is figure out how to properly get the distance of... Wait. I might almost have it. We got the dot product between that, and we already have the length. We don't need to normalize it because of that. So in that case, we can use this as a mixture between that and that. So in theory, that might actually get us the distance that might actually be working, potentially? Potentially. Which one looks like it's actually working? I should figure out how to actually... Yeah, I need to do actual tests to make sure this is working. Okay, let's go and break this out of the... What? I want to just copy, not cut. So here we're going to connect you to you, and then we're going to use the viewer to see the actual distance between all this. So here we can see that... Wait, is that actually working? Already? No way. That looks like it's actually getting the distance along the bone. And if we go and lower you... Oh no, that's just a point. Okay. So something is still off. Something is still off. We got the position. That... no. So, okay, let's, again, use the viewer node to see this. So this gives us a vector along... Which bone are we doing here? So that's the root bone. That bone. Dang, I really wish I numbered these correctly, because the way the edge lines are set up, it is not standard. Okay, let's go and take a look at the points, and look at attribute text. In their rest state, so let's go and use the separate transform. Let's see how this is going. Set that to be that. And I want to take a look at your index. There we go. So 0 will be you. So if all goes well, this bone will go from here to here. So if we take a look at the distances on the original mesh and turn off attribute text, we can see that it is not working whatsoever. So do I need to subtract that from the distance? I honestly have forgotten, which is not great. Okay, I'm gonna open up the other file, so please bear with me for 0.3 seconds as I go and open it. Do. Okay, what do we have here? Going back in time to where this was all just using the distance. Wow, that was a gigantic setup. Maybe I'll copy a plane over just to see. Edge interpolation, great. Okay. 1 second while I go and bring that over, everyone. We are cooking. We are cooking. Copy that plane over. Maybe one day we'll be able to copy node setups across blend files, but today I don't think they added that yet. So this is the setup. You take the both points, so this would be the beginning and that would be the end. And that would give you the interpolation gradient. So you get both of those and then do that. But I think if I should be able to get rid of that, and that should suffice. Well, anyway, let's go and give it a go. The order of these shouldn't really matter. So we can see that gives us a gradient along the bone. That is from 0 to 1. And if we go and do this, is that... Okay, no, that isn't 0 to 1. So it does have to be normalized. Huh. How about that? I feel like that could be eliminated, though. Anyway, we have that. So now we want to get the distance from there. So we can use this gradient to mix between the start and end points of the thing, and then get the distance between that. So this will be a mess of wires, but bear with me. So we get the distance from the position, and this should give us the distance along the edge. Oh, they're not swapping. Alt S? Alt S? Not deciding to work. That looks like if I go and move the shark down, yep, that's giving us the distance to this edge right here, which is great. So now we have the distance to an edge. So that's how you do that. Now let's go and simplify it. Oh god. Simplify it. We can delete you. And then we have you. But I feel like we can do this better. Because we get the distance between those, and we have to interpolate between that, which is less than ideal. I don't like that. So... Oh, wait. I also... a long time ago, when I was just a wee baby working in vector math, I was trying to get the distance to an edge so that I could make a collision system for that. Now I've done it with very little effort, just because I now know how dot products work. Which dot products are one of the best things that you'll ever use. So here, how do we make this a little bit better? Because I still want it to be a little bit better. A little bit more convenience. I do want to invert you, because this is still a little bit in terms of just how... There is something. I am missing something. I'm sure of it. Well, anyway, we can mix between those two, and that'll be the start of the edge and the end of the edge. So, edge interpolation, so that'll give us the edge position relative to the shark. And that'll be negative because that is in the negative, so let's just go on AB, but AB. Take a look. Yep, that is giving us the position, I think, but it's above 1, so let's go and divide this so that we can actually see what the hell's going on. So here we should see a slight gradient. So, yep, that matches. That matches pretty well. So that's giving us the distance to an edge. So, yeah. Now, it should be easier than this. Something's just gnawing at my brain, saying that it should be better than that. But, to be honest, like, okay, we're normalizing that, and then we're dividing that by that to kind of normalize it. If we were to normalize that one, then that would just give us the difference in the angle, which isn't good. But if we take that, no. This gives us the actual gradients. And then if we take the non-normalized version of that, that happens. If I were to scale this by the length of you beforehand, does that do the same? No. Divide? Then that would kind of just be doing the same thing anyway. Yeah. So I could do that beforehand, or I could just do float multiplication after the fact, which would be better. And I'm just double checking. What if I were to scale you by the length beforehand? Just making sure I'm not missing anything up. Divide? Just making sure. Nope, that's not working either. Okay, well, as much as I hate to say it, it seems like that's the simplest way of doing all this. Again, just giving us a gradient that goes from 0 to 1, and it's not clamped, but the mixing clamps it for us, which is, you know, pretty good. And then I'm just double checking. Just double checking, because it's still gnawing at my brain. Something is still incorrect. Wait a second, do I... No. That just absolutes it. Oh yeah, negative times... Yeah. I shouldn't stew on this, but my gut is telling me something, and my gut is always correct. Especially after it's had a very nice dinner. So this is distance to edge. So that's how you do it. You just need to find the closest edge. And that's how you do it if you search through every single edge, which, yeah, still a little bit. Oh, and I need to do one more test. The start and end points shouldn't matter. I'm just gonna do a little check again. Just a little one to make sure that I can swap these without any negative side effects. Uh-oh. Okay. Again. Yeah, no, it should not be. Yep, good. Same either way. Brilliant. Okay, now we have that. Now we can just go and eliminate that and that. Put you into a frame. And then send it in, and it should be all good to go. Very nice. Very good. I could just sample both the points instead of transferring the entire 4x4 matrix, which may be a bit more expensive to do. But I think it's fine. It's fine. So here... Yeah, I wasn't too far off already. But here, let's just go and take you... So, let's put you up here just to compact this. So, yeah, we are moving a lot more of it inside of the node group, which, to be honest, everything can go inside the node group now. Or I could just break it out of the group and there would be pretty much no difference whatsoever. But we can do you, and then connect you into there, and then boom, we have it all set up, and it is... Now, come on. Okay, so 5 milliseconds. Still twice the speed that we had before, simply because it's not using the geometry proximity node, but I did think that the savings would be a little bit better. But this is good. So now we should see that the shark is happily deforming, and the deforms are... Okay, there are still some funky things happening, which I will probably chalk up to the offsets. Well, no, that was happening before. I'm just going to chalk that up to the deformations being the way that they are. And then, yeah, if we do this, we should see... Yeah, that's just the interpolations being interpolations. This one is rotating. And if we make it so that the interpolation is even less, we can see that that happens. And then that goes basically to... Well, actually, wait a minute. Yeah, no, something's still wrong about that. Am I using the... No, this has to be the correct distance. I should also make it so that every bone will have at least a little bit of effectiveness. Now, in certain programs, you can only have 4 bones having weights. You can see... Oh yeah, we can see the distance ripples go through. And if we set that to smoother step, that leads to better results and pretty much the same time. Yeah, pretty much the same time. So again, if we limit the radius, which again, this should be by the bone scale. The bigger it is, the more influence it should have. But here we can decide how big it actually is. Wait, it seems like there's a phantom in there. There's a phantom bone, making it have a little bit more definition than it should. And also now, again, these will never have a distance of 0. So they will always be deformed. Wait a minute. No, it's not calculating right. What went wrong? Because for some... Or actually, maybe it is... Doesn't really look like it is. It looks like it's offsetting 1 bone over. Which is definitely not what should be happening. Why is Alt-S not working? I thought it would. So maybe I just have one of these around wrong. That looks a little bit better, but the tail's still incorrect. Okay, so it looks like we have to do a little fix. Oh, let me also turn that back on. I hope he posts the file on the end. If I get this... This probably will be a demo up on Gumroad for free, because, again, this isn't practical. But if someone has to do this, I want the information to be out there, because this is a huge pain to set up. Let's check this setup once more, and also let's, separate transform. We could also make it so that they don't even need to be turned into points, but I think it may be more efficient sending that through, because yeah, no, that'll be more efficient anyway. Let's take a look at the points once again. I want to take a look at their indices, because I'm going to take a look at index 1 or 0. Oh shoot. I did mess something up. I thought the root bone would... Oh, shoot. So, I did just a little oopsie here. For some reason, I thought... We're not using the chain index. We're going through just the index of the bones. And the root bone is not 0 in this case, just because of how the edges are laid... Or the points are laid out. So to make it ignore the root bone, I just need to say, hey, if the chain index equals 0, then just, you're not in the picture. Which I could do that either by just transforming, offset the transform of the bone up. Yeah, offset the rest transform of the root bone up. That would work. That would work quite well. I could not figure out how to control grease pencil color through geometry nodes. If it's possible, which actually I'm not sure if it is possible, because I think that may just be a material thing. It would either be a stored named attribute where you just store a color and then it can be used in the grease pencil shader, or it just doesn't have that option. I don't know. I haven't played around with grease pencil just because they're still working on that. Opacity works, yes. Opacity is just a named attribute. I remember that, but I don't remember one for color. You can store whatever data you want on Grease Pencil. I know that works, but whether or not it'll automatically show up in the shader, that I do not know. Uh, yeah, I don't know who you would ask about that, because I don't really know people who do that kind of stuff. Okay, let's take a look again at you, just to make sure I'm not forgetting anything major. You, I want to bring you down. So, wait a second, where... Why'd I delete the index? So, index, come on, buddy, of the points. So, right here, let's put you right there, and then take a look at you. No, that is correct. And the distance is doing its job. But yeah, the distance is doing its job. Maybe I just need to make it so that the distance will be more radial than horizontal, which I should be able to do. Again, I have the distance, and then I have the vector along that, so I could just scale that by that, and that could work. That could work. But no, this is... We're getting the SDF of a line. So in this case, it is a capsule. And capsules should work in this case. So, no, what we have does work. The only thing I need to change is the transform rest position, which I should probably do here. So if we move the transform rest position, so right here, we do this, but only on the chain ID. So that's equal to 0. We will set combine transform. We will set you to be just 10,000 meters up. Simple as that. Now, it won't cost this, it won't make this any more expensive because it's just already sampling that, which means that now this no longer, oh god. Oh, that's because, yeah, the weights, yep, instead of the weights being smooth. Something still just feels off with this. Like, the distance still isn't right, but it should be right. It's mixing between the two positions, and it's having a wonderful day. It should be having a wonderful day. That messes it up, that messes it up. We already know that's fine, because that's the actual position of the bone. Maybe it's just the... But no, why would... That... It's still wrong. I don't know why that part's happening. Maybe I could try to ensure it by... Ow. Just hit the mic stand, sorry everyone. I could try mixing it to 0 again. So if we take this and then mix it to 0. Excusez-moi. Ah. And that happens. We set this to 0. It is going through every single point, right? Going in there and it's going through every single one, going do 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 do. So both of those should be working. Bone, head / tail. There we go. Then there's the distance to edge. Yep, that part is fine and working correctly. And again, if you want to get the normal to that edge, you just use the subtract node, but that may have to be the other way around. But I am... This is quirky. This is a little bit quirky. We don't need you, because we already established that this works correctly, so we can eliminate you. So all in all, it is a smaller setup than before by a long shot. But something is still incorrect, and it is annoying me. But I know it is solvable, and fairly easily as well. Just need to get there. My brain needs to calculate. Or, no, it didn't calculate, no. It needs to just figure it out. Let's see, let's bring you over to here. Actually offsetting it by that is fine. We don't need to worry about these two. The normalization of the offsets is perfect. Would an attribute blur on the weights reveal the interaction between the bones? Potentially. I'm very hesitant to try that since... Yeah, no, something's wrong, because this one should be... The distance between that, it should be getting bigger there. So, it's, for some reason, just ignoring parts of the bone. The shark's in the same place, we don't need to worry about that. It has to be you. Because if we just hook up the distance, in this case it'll look at the tail. It's Wait, what? Why are you doing that? Why are you doing that? That doesn't make any sense. It's the rest transform. And the only part that is... Huh? The chain ID is equal to 0, then do that. Okay, so we found the error. Why did the chain ID disappear? The chain ID is essential. It has to exist. You are... Chain ID? Attribute text. 0 and 1 are right there, so if we have that, then there is a true in there. Yeah, there is a true there. So we do that, that gets offset. So only the root goes up. By a long shot. Like, very, very far. So what is the problem here? What is its problem? Oh, looks like we need to do another little check. So let's, set position, and then get the rest transform. Separate transform, put you into there. Let's see what's going on. So again, you make you. Excusez-moi. Are you equal to 0? All the other ones should be null. Wait, am I just tired or something? Because I am failing to see. Yeah, you go up and the rest are fine. Yeah, no, all of you are in your right places. So yes, that is absolutely correct. You go up and everything is perfect. You just go up. And the tail is perfectly fine. You just move that around and that's all good. So, you're all fine. So if we take a look at you and ignore you, you still freak out. Why would that cause that to happen? Huh? Something's still very wrong. But what? Both of these are... Okay, I must be missing something very obvious. Because they were doing that. Oh, wait a minute. Yeah, that part's fine. So now, if we hook this up, you should be seeing that. Yeah, it is matching pretty... Okay, that was fixed. I don't know why that happened. Okay, wait, what? Now, wait, what? Now it's working. Wait, what did I do? We had the distance to edge working properly before. Okay, what? What? Okay, so apparently I was... Oh. It does affect it. Okay. Well, I really don't want to do a check for the chain ID for every single bone. I really don't. I don't want to say, hey, if the chain ID equals that, then don't do anything, because it just keeps getting stronger, which it really shouldn't. After it goes over a certain distance, it stops being effective. 100%. And he... Oh... I understand now. Could I just... delete? I can delete one of the bones and everything will survive, right? You just delete that one and everything's good? Yeah. There will be one unnecessary, which I could just go and use a subtract. The point count is that, and that'll go from 0, 1. Actually... Nah, that's fine. That's just ignoring the root bone. Ignore roots. So again, with this system, let me just explain once more. This is... Here, we could... This is setting the weights and doing the skinning in one go, which is not recommended. You know, you want to have named attributes with the weights, and you can set those weights using geometry nodes, but you want those to be pre-baked. All you want to happen, at least with my system, which is, again, not the best, is to stack up the weights and then stack up the offsets and then do that, so that's normalized. If you have multiple bones with values of 1, it will auto-normalize them. So I'm replicating that here. So there we go. Now the shark is moving and all that's good. The most annoying part of this is that I need to do a distance to edge. I have to create my own, which, hey, that's a fun little tidbit right there. Just create your own distance to edge node. Which, it wasn't that bad if you know what you're doing. Which, it took a little debugging, but we got it. So there we go. Now all of this is feature complete. Or, I should not say that. This is now workable. It works. Which is good. And nice. We have both of you in there, and it does that. It goes into there, and then boom. This is now somewhat of an armature. Now, I'm still unsure if I want to use the armature offset, because it's one or the other. Either I separate... Actually, wait, what if I did this? Let's do just a little test, and let's also do another little test with doing that. It's still propagating a little bit weird. Actually, no, it's not. Is it? No, it's working correctly. These ones are moving that way because the shark is smaller on that side, and that one's moving that way. Okay. Nope, those are working correctly, so let's just do that. Nice ease. Then we can make it so that that happens. Okay, no, it is working as intended. Is it? Still? Something still feels off, especially with the tail. It's not just that... It's as if the shark is too high up. Which it shouldn't be. We go and do this. Oh, maybe it was too high up. Because that's supposed to be on the center line, so maybe... something's still a little bit off. We can experiment with that. Here I'm going to combine the transform again, so that it'll remove any shearing. It'll just be a location, rotation, and scale, so this should... Oh. Do nothing. Alrighty then. If we move the offset, so if I were to just transfer these and then do the offset after it's sampled, this will be much more expensive, as we will see. Oh, it's actually pretty much the same. How about that? But do we see a big difference? No, not really. Not really. Okay. So it should be cheaper if we just do it on the points and then those get transferred. Or if I want to be greedy, I can use a capture. Would a capture attribute node work here? Because with the repeat zone, I'm not sure if this would calculate again and again and again, or if this would make it a lot less expensive. Nope, same thing. Okay, don't need to worry about that. Good. Good, good, good. Okay, so we have the repeat zone. Oh wait, I could... So there's this fucking... funky. Funky. I said funky. But a syllable just did not pronounce. Oh, that's funny. We have the for each element zone, which I forgot we had. Classic, classic, classic. Classic, classic, classic. Classic, 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 Ben. Classic. But actually... You know what? It's fine either way, if I'm being honest. And it's future-proof. If we ever get the ability to go through every single vertex group, that should work. So, okay, I'll try it with the for each zone. But that could, well, I don't know. Don't know, to be honest. Interesting. Okay, okay, okay. Very interesting. And we can just ungroup all this so that we only have one thing here. Though, actually that's not too bad. We just connect you to there and there and there, and then that would be fine. Let's save this before I do anything rash. And also, let's try the for each zone. So, for each point, we'll be getting certain data. Like in this case, we will convert the rest transform and U, and now we have both of those. And then with this geometry... Oh, wait a minute. Oh, wait. Can we even do that? Because it's for each point. But if we have other... I forget. Can we pass that through there? Because we're... Oh, no, wait. We're repeating on the shark geometry, not on... that. But no, that should work either way. Oh, but maybe it would... Wait. It would spit that out, but that would spit out a different shark. It would spit out several different sharks for every single thing there. Nope, that doesn't work. Okay, so... And I need to I keep forgetting that we have the for each element now. I spent way too much time in the older versions of Blender. There we go. There we go. Okay, so for now, that's okay. And we can go and ungroup. And then boom, we have the entire setup here, which... that is a little bit bigger than before. Is it? Wait. Toggle window full screen. Let me go and open up the other one. I just want to see, do a little size comparison here. Let's see. It is bigger. It is bigger. But not... it's more complicated. It's better. And probably maybe fewer nodes. But having to do the distanced edge does... Is the 4H already in a stable 4.3 build? Oh, it's just in 4.3. Like, in the main release. 4.3 came out months ago. It is... the 4H zone is in. It's in the current version of Blender. So, yeah. I keep using Blender 4.1 for some things for my job, because Eevee next, like, in other stability things. So I keep forgetting that, I keep switching between the versions, and I keep forgetting which one has which features. Like, I know in 4.3 we have the Matrix, which is why I'm doing all this. Because this would be a huge pain if we didn't have the Matrix nodes. A humongous pain. Absolutely atrocious. It would be possible, but just extremely annoying, because I would have to sample... well... No, we would have to sample... I would have to make multiply matrices, invert matrix, and all that fun stuff, which, you know, is... Oh, no, you don't want to make an invert matrix. No. Don't, no. Just don't. Just don't. Yeah, use the matrix nodes. They're there for a reason, and they're good. But yes, we have all this, and that is pretty good. That was just an alpha build when I saw it a couple of weeks ago. Nope, it's in Blender now. There may be more 4H zones coming in the future, but for now, you know, it's 4H geometry piece, which is perfectly good. It's perfect. Very useful, but in this case, unless I'll need to refresh, but it would work on all the points and then spit out geometry based on that. While here, we're editing the shark again, and again, and again, and again, and again. And this one does have to be done sequentially because we store up the total weights. Did you update your rigid bias system with it? The rigid bias system... That's staying in retirement for now. While it is very close to being done, extremely close... Well, no, I shouldn't say that. The rigid body system... Using default geometry nodes, not the builds, getting the collision points is something that I cannot do. I've tried to do it, and it's kicked me in the rear several times. For that, I just can't do it efficiently, because not only do you need to get the collision points for each object in the environment, you have to collide with other parts, other rigid bodies. So... I can't do it. I thought the 4H was what was missing. The 4H would help, but it's a skill issue on my part. The Blender devs are working on, or one of the Blender devs has experimented with implementing Jolt as a rigid body system inside of geometry nodes, which is why that project is on hold. Just because no matter what I do, it won't be as good as the rigid body physics system that was used in Horizon Zero Dawn. That's literally where it came from. The people who made Horizon Zero Dawn made the Jolt physics system. Or, wait, it was used in Horizon Zero Dawn? I forget if they made it. But it's now open sourced. There's a few asterisks at the end of that. And now other people can use it. Now, the person who made the Bullet physics system recommends the Jolt physics system. So if Blender is going to be updating, it should use Jolt. Especially, you know, with the old rigid body physics system here, it should use that as well. Because we still need the object-based rigid body physics system, besides just having a geometry node version available, just because we need the actual objects to move instead of just geometry. Because you may not want like every single object in your scene that has rigid bodies to be just one object with a geometry node on it. In Houdini, everything would be in like a scene or collection node, then all that would work from there. but the Blender just isn't set up that way. Geometry nodes is made to replace modifiers, not the entire system of Blender. So, yeah. Let's see. Well, it would be nice. It is just a technical challenge on a geometry node's front. Okay, so all this is here, so that is the weighting. I do want to keep that inside a node group, even though it would be so incredibly easy. Actually, I could put you. I could make a node group out of you. That would actually be a good idea. Let's go node, make group. And here, we can do this a little bit differently. We will use a subtract. Oh, but then I'll have to, that's fine. Then get the length. So that we get the distance and the normal. So this will be the distance, and this will be the normal. But I may have the normal inverted, which isn't good. But yes, distance to edge. We can flip this back around. This will be end 1, and then this will be end 2. End 1, end 2. So, distance to edge. Or edge SDF. Edge SDF. Nah, distance to edge. That's good. So if we do that, we have a very nice node group right here that handles all that for us. And I will do one more check. Let's do you and then you. We will check you and turn off attribute text so that we can check you, and then you should be at like -1 or something. Oh wait, no, that should be Y so that we can see that. So that'll work there, and then the normal should be facing away. So again, if we use a fraction node, multiply fraction. There we go. So that's working. But if we were to, like, let's go and extrude mesh. Oh my god. And then we do that. These should be facing away. So that was facing the wrong way. So now, if we take a look at you, you should be facing away from the edge. Oh wait, that needs to be, the normal needs to be normalized. I forgot. There we go. Now that's the normal away from said edge. And we have the distance, so you could return, you could go and restore the length if you want, but this is just a good way of doing it. So yes, that is how you set that up, and I'm pretty sure that's the best way. Again, this part does annoy me, but I think that's the only way. I can't think of another way. Because if we have that, yeah, no. And then you need a lerp between those two, which is, you know, as expected. Yeah. Yep. It is what it is, I think. Is the distance to field just not similar to an SDF? Well, the distance in an SDF, it's... I forget if there is actually a big difference between them. Or assigned distance field is signed, where the outside of the mesh or the surface is above 1, and the inside is -1. That is the purpose. Well, in this case, I could do that. Actually, wait, let me get the demonstration back here. If I use a subtract here, since we have the distance, we can turn this into a signed SDF in a way. Just because... let's get you back here. Oh, right, there we go. Just because there, we can just mark what's less than 0. Or, yeah, we could just use a sign node. This will give us the sign of our distance field. So here it's above 1, and here it's -1. So, yeah, it would work. Yep. Would work. But here, you know, it's just the distance, and then you can turn it into signed SDF, you know. But yes, that is that. Very, very nice. So, distance to edge, that works just fine, and then we have that, and then we have that. There's also an input for a signed and unsigned angle. Well, if you want to unsign it, you just absolute it. You can do that in post. It's not that bad. Not that bad. Let's see. Can you explain... Oh, wait, sorry. Can you explain the distance to edge part in detail? The dot product magic I don't completely understand. Dot product is an amazing thing. Your favorite nodes, like reflect, project, they use dot products under the hood. At least... I would have to double check on that. I'm getting tired. Oh, we're past an hour. Yeah, no. Past an hour. That was my time limit. But here, let me go and explain this. So we have edge 1 and edge 2 of the point. In this case, we subtract between the first part of the edge, which gives us the offset to that point. And then here, we get the vector between point 1 and point 2. So if we normalize this and then dot product it, I'm going to ungroup this for the time being, just to actually show you. So let's use a combine XYZ to actually make this. So let's visualize this instead of me poorly explaining it. So here, let's take a look at the shark, our shark buddy right here. Here we have the offset to the first position, which in this case is Y0. So, or wait, maybe, which one goes where? Yeah, no, we get the offset to that one. Oh, and that's inverted. Well, does that need to be inverted? Actually, let me double check that. That leads to that. Okay, so quick little thing, we need to swap those two. Not too important, but okay. This gives us the offset to the start position. So in this case, or wait, maybe that was supposed to be the other way. Because that's the it's fine. This gives us the offset to that position, so if we were to put in a length, that would give us the distance to that position. So in this case, we can see that's the distance to the start position. And then here, we have the offset between the 2 points. So in this case, it would be the vector along that, which would be y something, y3 in this case. And then after we normalize this, this means it will just be y1 and then dot product it. It gives us a gradient along the vector, along the normalized vector. And then we normalize this vector to between a gradient between 0 to 1, as we see here. So if we were to then fraction this, fraction right here, we can see that it goes in increments of 1. So if this is set to -1, that'll just mix between that. Then that mixture just mixes between position 1 and position 2. So all of this is to just mix between position 1 and position 2. So as it does that, we can now see that this gives us that, and then we get the length, and it will give us the length along that edge. So this is just a fancy way of saying how far along the edge are you? And then this is mixed between those two, and it works out beautifully. So let me go and fix that real quick. We just need to swap those inputs. I'm not sure if it actually has to be swapped, but, you know, it just feels a little bit better if it's done like that. We get a little extra space. Nice, nice, nice. Boom. Incredible. Yeah, that's pretty nice and solid. A nice shape of the nodes right there. Not too bad. There we go. So that's how it happens. It's, dot products. Very good, very good, very good, very good. Very useful, essential. Especially, like, before, when I was doing quote-unquote matrix math, or matrix transformations without actual matrix nodes, use the dot products to go and get the axes of the matrix, and then you can reproject those, which is really good. But now we have the matrix nodes, so I can forget all that. not forget, but, you know. Dot products, when you unlock their full potential, are very useful. Because there's level 1 where it's like, oh, 2 normalized angles, it'll give you a value between those, and then you can get the angle between 2 vectors, which is good. I use it in the limit vector angle setup that I have to where 2 vectors cannot be angled too far or else it'll just limit it. That's useful, but when you unlock the full potential, it is an extremely useful node for advanced stuff. There we go. So, the change is complete. Now the only annoying thing is separating the matrix columns, but I cannot change that. That just is what it is. We can't really edit that. And then beyond that, everything is perfect. Right. And we can delete whatever bones we want, and they'll just be ignored. That is lovely. Actually, could we do... Maybe I can make this even more efficient by about... No. Don't get greedy. Don't get greedy. Now, again, the reason I'm not using the geometry proximity node with an actual edge is that this, the proximity node, uses a KD tree. Well, actually, I would have to check the code again. I'm assuming it uses a KD tree under the hood, and I would have to separate the geometry. So in this case, I'm just saying, no, you're not determining which edge is closest, you're just going over all of them. And in this case, the edges aren't even real. They're just the endpoints of the bone. Which is good. So with all that done, this is mostly complete. Now there are still some quirks, which I'm, again, assuming is just the weights that I auto-generate. Because again, auto-generated weights will always be just a little bit quirky. That's still looking a little bit off. Oh no, that... I know why that's happening. Maybe I should just make it so that it ignores... I could make it so that it ignores the distance, so that it only takes this axis into the count and not the other ones. I could do that, because we already have the gradient here. I could try that. So that it doesn't get the X, Y. Just gets U. So I could use a vector projection to do that. Or, vector rejection, potentially? So that we flatten, or... I'm too tired for that. I could make it so that it only gives us the distance forward and backwards of the bone, and ignores the up, down, the side-to-side ones, and that may be a little bit better. But no, we still need that. So yeah, no, this is good for now. Even though we're making... Oh wait, there's no tail fin. I forgot to put in a tail fin. So now, oh, but I do want to... I want to call this, but I want to try this out on a human. Maybe a little inhumane, but oh well. And I could go and freeze that bone, so that it'll stay rigid compared with everything else. So now it has a tail fin. Oh, it's spine. It's spine, oh god. I need to put in the limiter. Let's go and turn on the limiter to be 45 degrees so that it cannot break its spine anymore. And there we go. Now the tail fin is doing its job. Side fin, you know, even though, like, I should have put, yeah, no, let's make it so that that bone is connected there, and then this one isn't. There we go. Reload, and there we go. Now, that part is connected to that. That doesn't feel right either. That's a good thing about this. We can just go, create, and remove bones willy-nilly, and it works out very nicely. Limit the angles, do the, like, the springiness part there, oh, I could make it so that it just calculates the chain iterations automatically. That wouldn't be too bad, but it's fine. So yay, armature stuff. So now let's do this on a human. Let me go and get a human real quick. Let's go and save because we have all the good stuff. Human form. Let's go and get one of those. This is going to be absolutely terrible, but hilarious all the same. Oh, let me read the chat, by the way. Let's see, all that. No, I did all of that. Oh, you have to go. Okay. Yeah, have a good one. I hope you enjoy. Let's copy this human form and put you in here. A nice human base mesh to be our experiment. So now, let's go and make a new rig. So in this case, we will delete everything besides the center point. So here, and in theory, well, it all still needs to be attached, so we'll have you, the root bone, be here. So this is going to be real inhumane. How many stream requests do you get, by the way? A fair amount, but I don't take stream requests. Just because this is like a log of my experiments rather than... I mean, you can mention them, but I cannot guarantee whatsoever that I'll actually do them. Just because these are, you know, my little experiments. Just doing what I do. And oddly enough, this is the most motivated I've been to do geometry node stuff in months, and it's a project that has pretty much no practical use whatsoever. Isn't that great? Now, I guess this might have some practical use, like if you need a highly, well, it's impractical. Let's just leave it at that. I could even put in fingers, and it would work out okay. Sorry if I'm sniffly, by the way. I've been a little bit under the weather. Let's see, we could do that, and then make sure you're the roots. And then that will be really bad. So I'm going to freeze you. Then I could use a mirror modifier. That's a good thing. Like, we can use all the fun modifiers here. So, have you ever mirrored a rig using modifiers before? Because it works. Oh, wait, what? Ah, that's what's up. So now we have a fully procedural rig. And it's not doing anything. Why no see you? Root? Oh, wait, the group was assigned to everything. Let's go and assign you here, and then maybe... There we go. So now we have... Oh, this is going to be... Well, time to do it. Let's do, geometry nodes, armature skinning. Wait, no, not the shark. You. Oh, wait. Something's up. Rotation? Ah, there we go. Oh my god, that's horrific. Well, if you... Oh my... Oh, that is extremely unsettling. He's made out of jello. He doesn't really... Oh wait, I could make it so that his hips are frozen. That may help a lot. So, you doing better, buddy? Or are you still having a very bad time? Okay, let's make this, human. Oh my god, it actually worked. Is this a good thing? I'm slightly annoyed. Well, wait, is that the root bone? Wait, what happened to the root bone? This is in world space, so I could add other forces if I want. I could, okay, so let's disable you. We do, yeah, the root transform will just be 0, 0. Right there. And now let's make him suffer under the weight of gravity. There is the limit. I could turn... This was a mistake. This was a big mistake. Let's change the angle limits. This was a huge mistake. I should not be trusted with this level of power. This is horrible. What have I done? Okay, I'm going to make it so that since this is really bad. Let's make it so that's a little more on the lower back and see how the Well, I made the Wiggle Bones add-on. Is there any questioning that? Under the weight of gravity. What have I done? I do want to hide the root bone. Yeah, let's go and hide the root bone. Which, that does remove it from the setup entirely. Oh yeah, yep. That's good. What have we done? I mean, this is one of the most hilarious things I've ever made. But should it? God. Okay, I could put in like the distance smoothing for that and just lower it by a bit so that there's a little more internal structure. No, but something still feels wrong with that. It's like if yeah, no, something is still I'll do a few debugging passes on this because some of the armature stuff is definitely not working as intended. Can you give the mesh some pressure scaling the normal? I'm a little unsure what you mean by that. Give it some pressure. You mean, oh, like making it an actual balloon using a cloth sim? This is absolutely terrible. What have I done? I can do this with anything. I could even add in collisions if I wanted. Well, actually, I would have to create another system for that, but... yeah. Like yeah, look at that. That's not supposed to be doing that. The distance should be better. Like if we make this a less than node, this will make it so that all the cutoffs are harsh for the most part. And we can see that even that's not working properly. So there is a discrepancy between the different pieces of the setup. Even though it should be normalized. A few quirks. What's the harm? We got the main thing done, and we... This is something special. This is something special. Okay, let's go and limit this even further. Because right now the limits are very hard. Like, the limits are essential. It cannot move past this point. So now it's a little more realistic. The hips. The hips are in the wrong place. They need to go up by a bit. Right? Or maybe you have to go down. Maybe that's what. Yeah, there we go. Now, another thing is that I cannot, I can't separate... well, actually, no. That's not an issue. With the parenting has to be explicit. Like, it needs to be an edge line going from one bone to another. But I can freeze them, which basically... yeah, no. The parenting is perfect. Parenting is perfectly fine. Now, the only thing left to do is make it so that you can actually see the armature inside the rig. This is great. I love it. We can see that the orientations of the bones are staying the way they should be. I could even add in as many bones as I want. I could add in bones for fingers. I could add in bones for I don't know where else would have bones. But yeah, I could add in more spine bones if that's what we need. But I think that's good. I could do one other thing, but you know, you could just subdivide the bones and call it a day. Now it is truly Spaghetti Man over here. Oh, interesting. We're getting some, yeah, the deforming artifacts that you get with, when your arm weights are... Yeah, no, this is actually looking right. Would you look at that? Okay, let's go and bring you back to reality here. And also, we could have multiple attachment points. I could make it so that the torso and the bottom have different, attachment points. This is great. I did it. I actually did it. I didn't think it would work, but it does. We don't need you attached, so I could turn up or down the dampening, so now it doesn't look all too realistic just because it's so limited. But the constraints are working very nicely. And again, the angle limiter, I'll show you this once more. This will limit the vector angles with, you know, you get the normal, the vector that it'll be limited from, and then the vector to be limited. And then this is the setup. You get the angle between the two vectors, and then with that you clamp it, which in concept it's very simple. Then you rotate the normal vector to match the other one, even though it's clamped, and then you set the length to be the limited vector. And that works out well. There we go. And you can make it so that it'll have to be. Now that I changed this, it can never be straight, so he will forever have scoliosis. But yeah, so many options. Look at the possibilities. Mostly impractical possibilities, but it is absolutely hilarious. Let's see. Please put on gum road. I'd get it right away. Collision in addition would make it perfect. I could put in collisions right now. I could. It would be pretty simple. At least in this form, it wouldn't be like full collisions, and all the collisions would have a set radius. Because I've already done point collisions before, and in this case, we don't need to do... No, we don't need edge collisions. We would only be able to do point collisions, not edge collisions, which in this case is fine. Just having the end point and the beginning point, yeah, that would be fine. So now, oh wait, this would work for hair. Mesh rigged hair. Yeah, no, this would work. How about that? I'll need to try that. And I would have to put in delta time, but that's not too bad. And putting in the, like, this, again, this is the stiffness. Flying like a eagle, piloting a blimp. Just so happy to be included, you know? To be able to soar. Okay, we'll save that for another time. Thank you all for watching. I hope you enjoyed this horrendous experiment that I've done, but it turns out it was successful. We could also make it so that the character, again, has a more rigid spine, or we can make it so that he's a little more, you know, a little more floppy. Having just the time of his life. Could I even use ungenerated edges? As long as you assign the start group, which... Oh, yeah, the end vertex. As long as you have that assigned to something, it will work. And then I do need to make it so that the iterations are... It just auto finds out how many iterations there can be. Alright, everyone. Thank you all for watching. This was a horrendous experiment, but it was very successful. And, yeah. Look at that. Even though I do need to randomize the stiffness a little bit for each bone, which I could do just with a random value node. So random value, just so that, you know, some of the bones are a little bit, so there, you know, there's some asymmetry. So much potential. Dang. it actually works. Alright, thank you all for watching. I'll see you next time. Have a good one. And with 10